Hello, my name is Steve Bowler, and welcome to the Juniper Intermediate System to Intermediate System ISIS Lab number 1. In this lab, we're going to take a look at the basics of ISIS. So first, I'm going to explain our network topology. We have two routers, router 1 and router 2. They are connected together via the 12 network. Router 1 is the .1 IP address, and router 2 is the .2. We are using logical systems in this lab. Router 1 and router 2 belong in the same Juniper router. They're connected together via logical tunnels. So if you're not familiar with logical systems or how they work, you can watch my logical systems labs where I explain in detail how to set them up. What we're doing in this lab is we're creating logical systems, and we're just going to bridge the connection together using logical tunnel interfaces. Router 1 is the LT120.12 and router 2 is using the LT120.21. We also have a loopback 0.1 on R1 with the 1 and 11 networks, both /24s. On router 2 we have interface loopback 0.2 with the 2 network and the 22 network, both of those as well /24s. And what you're going to see below those is you see a very long number. Might not look familiar. This is what they call a net address within ISIS, and I'm going to explain this whole address in detail in this lab. So the first thing, let's go ahead and just start by explaining some of the basics of ISIS. It was started by supporting what's known as CLNP, our connectionless network protocol, IP support, which what we're going to use in our lab. This was added later on. It is a linked state protocol similar to OSPF. It uses PDUs, protocol data units, for network information, and there's multiple types of PDUs. You have hellos, you have LSPs, you have complete sequence number PDUs, and also partial sequence number PDUs. So what we're going to do is we're going to try to break down some of those and explain to you why those are used and in what situations. ISIS also runs the shortest path first, our SPF algorithm, just like OSPF, to find the best path through the network. And what we're going to see is, the first thing let's go ahead and talk about in this lab that is unique with ISIS is that we have this very long address, and what we're going to see with ISIS is that we only need one of these configured per router. And this is again to support ISIS. This address is called the network entity title, our net address. And the reason we see this is that because ISIS was initially designed for the OSI network protocols and not TCP IP support. Like we talked about earlier, IP support for ISIS was supported later on. And what we're going to see is the first, from 4 to 1, are the first 6 numbers. This is what we call the area ID. And what we see most commonly is 49 being used as the first 2 numbers, and then we see 0001. And if we were to put in 49002, that would be a completely different area. And then the next 12 numbers, so from 0 all the way to 1, this is what's known as the sys ID, our system ID, and this identifies each router uniquely. And what is very common in operations when you're configuring ISIS is to have your loopback IP address, your IP version 4 address, within your system ID. So what we can see is we are using, and these are in leading 0 notation. So we see 001 represents 1, then 001, then 001, and 001. So if we wrote that all out, we got 1.1.1.1. And that's exactly what we're going to see under our interface loopback 0.1 on router 1. Same thing with router 2. We have it in the same area, so 49 0001 is the area identifier. So this is single area, I guess you could say. And what we have is leading 0 notation of our loopback 0.2 IP version 4 address put in as our system ID. So we have 002, 002, 002, 002. So it looks very long and confusing, but what a lot of people do is they put this in for simplicity. They just, that way they have the net, when they look at the net address, they can say, okay, well that is coming from, router 1 because it's the loopback 0.1 IP address. And then the last two zeros, you might be wondering what those are. Those are called the N cell or net selector, and these must always be 0 to indicate that that is running in this system. So that's the basics of a net address, and what we're going to do now is we already have the IP addresses configured. What we're going to do is that we're going to configure our net address. One last thing about net addresses before we configure them is that usually you want to put your net address under the loopback of your router, just like other routing protocols, because this is what we're going to use to speak ISIS and run ISIS protocol. So if we put this address on one of our physical interfaces, then it goes down, then it can mess up the overall operations of our ISIS network and design. So just like OSPF and other protocols, you want to put your router ID, or I should say you want to have your main IP address reachable via the loopback, because we all know that loopback interfaces never go down and they're always reachable. So what we're going to do is we're going to put our net address under our loopback 0.1 interface. So let's go to router 1 first, and we're going to go ahead and do this. Under R1, we're going to do this. If we go under Edit Interface, we'll go under Edit, we'll get into configuration mode. Now we'll go under Edit Interfaces, Loopback 0.1. And if I do a space question mark, you see that we have the family, which is going to indicate our protocol family. If we do a space question mark, you see that we have iNet, iNet6, obviously IPv4, IPv6, and then we have this right below it called ISO. This is the OSI protocol parameter. So this is what we're going to use for our ISIS operation. So we'll go under Edit Interfaces, Loopback 0.1 Family ISO, and then this is where we're going to set our net address. So we're going to do the command set address, and then 49.0001. Remember, that is our area identifier. And then this is where I'm going to put in our system ID, which uniquely identifies each system within our area. So 001, 0001, 00.1, 001. And then our last two zeros. So we'll go ahead and commit that. And then now we'll go under router 2, do the same thing. First we'll go under Edit Interfaces, Loopback 0.2. The family we're going to use, instead of iNet, remember we're specifying our ISO address. This is our net address. We're going to do set address 49.0001. Remember, this is within the same area. We're going to talk about areas and then the types of routers in that area later on in this lab. So 49.0001. Then we're going to put in our system ID next, which is going to be, remember, leading 0 notation. This is going to be our loopback. So we're going to do 002, 002, 002, 002. And then put in our last two zeros for our N cell. And this is our loopback IP address. This helps us identify more efficiently and easier. It's just easier to identify your address for ISIS. So it's a best practice. So we're going to set our address. Let's go ahead and commit the change on R2. And if you remember, we only need one net address per router. So what we're going to see with ISIS is that we have one net address, but you're probably wondering, well, then how do we start sending hellos across the interfaces? How do we advertise interfaces into ISIS? And I'm going to explain all this in detail. The first thing that I want to show you is just real quick under router 1. If I now do a show configuration, you can see under loopback 0 unit 1, in addition to family INET, we now have family ISO specified. Then we have our net address that we set up. So I just wanted to show you that. And the next thing that we're going to do now is we have configured under our loopback family ISO. But what we're going to find out with ISIS is if we want to start speaking ISIS across our interfaces that connect router 1 and router 2, which is the logical tunnels, we're going to have to specify family ISO under those interfaces as well. So we're going to go under router 1. We're going to put in set interfaces LT120.12, and then if I do a space question, we have protocol family again. Then that's what we're going to use. We're going to do family, and then we're going to do ISO. So let's go ahead and commit that on R1. We'll go ahead and do router 2 as well. We're going to do the command set interfaces LT120.21 family ISO. Go ahead and commit that. And if I were to go to router 1 and do a show, one of the first commands that we're going to use to verify ISIS, the ISIS protocol, is show ISIS adjacency. And right now what we're getting is, what I wanted to show you is that it says that the ISIS instance is not running. And so you might be wondering, well, if we look on R1 and do a show configuration, we have family ISO now specified between router 1 and router 2. We have family ISO under our loopback. Let's go ahead and verify this on router 2. If I do a show, we see that we have under unit 21 family ISO, and we also have the loopback for family ISO. So there's one last thing that we have to do, and we need to set up ISIS under the edit protocols ISIS hierarchy in order for the adjacency to come up. So what we're going to do is under router 2, we'll go under edit protocols ISIS. If I do the command set space question mark, we see that we have the option for interface. So we're just going to do set interface and then LT-120.21. So now if I go to the top of the config on R2 and do a show, we now have protocols ISIS showing up, and then we have our interface connecting router 2 to router 1 underneath it. So this is another step that we have to do to get ISIS up and running. On router 1, we're going to do the same thing, but before I do that, I'm going to enable trace options under ISIS on R1 so that we can take a further detailed look at some of the events that are happening with the ISIS protocol. If you're not familiar with trace options, you can watch my trace options lab in which I configure trace options and verify in detail what they are used for. They're similar to the Cisco iOS debug commands. So what we're going to see is if we go under edit protocols ISIS on R1, I can do the command set trace options and then name a file. We're just going to name it ISIS lab 1R1. And then once I have the file created, now I need to do the flag where I come back in and say, okay, what ISIS events do I want to send to my file that I just created? In this case, we're going to flag all events. If you're not familiar with trace options, I would suggest watching watching my trace options lab. That's all I'm going to really say about the trace options right now. And by setting the all flag, this is going to catch all the events. We're going to go through and just take a look at a couple of different events that are happening with ISIS, and I'm going to show you how we can match on particular events to siphon through all of that log file, because as you might imagine, ISIS is like OSPF in that it is a very chatty protocol. It runs SPF, and there's a lot of information that you're going to get if you flag all events. The next thing that I want to do, if I do a show under ISIS, I don't have any interfaces that I set up yet, so I'm going to do the command set interface lt120.12, just like I did on router 2. Let's go ahead and commit that. Make sure I have it committed on R2 as well. And now on R1, if I do a show ISIS adjacency, now what we can see is that we have an adjacency with router 2. We're showing the interface that connects the routers. From router 1's perspective, this is our logical tunnel 12. The system, and what's really cool with ISIS is that it resolves the host name. So in this case, we have Juniper Lab R2, and that's exactly what excuse me. That's exactly what our router is named on the other side of the adjacency. We have the L, and I'm going to explain that in detail. One of the first things that we know about ISIS, or one of the first things we need to know about ISIS, is that there are not a lot of, you have L1 routers and you have L2 routers. And you also have what's known as an L1, L2 router. And an L1, L2 router is similar to OSPF and area border router, in that it is in between the different areas. So you're probably saying, well then what is L3? So this indicates that we're running both an L1 and an L2. So what we're going to see with ISIS is that L2 makes up the backbone, and L1 routers are within an area. And then an L1, L2 is connected to both another area and the backbone. Now if I do a show ISIS interface, we can see that we get a little more detailed information. We have again the interface that we're connected to our adjacency. We have L3, which tells us it's both a level 1 and level 2 device. And what we're going to have to do, and we'll do this later on in this lab, is we're going to specifically disable it from being a level 1 router, and then we're going to disable it from being a level 2 router. And we're going to see some of the differences between a level 1 router and a level 2 router. Because right now it's a level 1, level 2. And we also have the circuit ID. We have level 1 designated router to level 2 designated router. We see that right now this is a point-to-point connection, obviously because we are running frame relay. We have the level 1 and level 2 metrics shown as well. And it is important to note at this time that we show point-to-point for the DR and point-to-point for the level 2 DR as well. Now ISIS is like OSPF to where on a broadcast multi-access network it's going to try to elect what's called a designated intermediate system, or DIS. And in this lab, we're not going to be worrying about the DIS election because we simply have a point-to-point connection. One last thing to point out is that the metric is 10, and this is the default IS-IS metric for all links, except for the loopback, which is indicated with a metric of 0. Another good show command, now that we have our IS-IS adjacency up, is the show IS-IS overview. And what this is going to tell us is the router ID. This is going to give us a little more information. We have IPv4, IPv6 enabled. We also have the different levels. We have level 1 and level 2. And what this is telling us is that we have different route preferences between the different levels. And we're going to see this once we add, if I do a show route on R1, we can see that we don't have any routes learned via IS-IS yet. So the route preferences we're going to see are going to change based on whether we have a level 1 adjacency or level 2 adjacency. Right now we have, between R1 and R2, they are both running as L1, L2s. So we can see, obviously, that level 1 has different route preferences than level 2 routes. So level 1 routes are preferred over level 2 routes. So on R1, if we do the command show IS-IS adjacency detail, this gives us a little more detailed look at our adjacency to router 2. We see the name of the router that we're adjacent with. We can show priority values. We can see the circuit type. And now what this is saying is that this defines the router type. Like we were talking about before, where we have level 1. So if this was a level 1 adjacency, we would see the circuit type as 1. If this was a level 2, we would see the circuit type as 2. And obviously, by default, on our Juniper routers, we're seeing that we are speaking as both a level 1 and level 2 device. So that's why we're seeing the circuit type as circuit type as a 3. And on R1, if we do a show log, IS-IS lab 1R1, what we are receiving is we are receiving L1s and also receiving L2s from router 2. So that's why we are a level 3, or I'm sorry, not a level 3, but that's why we are acting as a L1, L2. We're sending and receiving both of those. We can see CSN, which is, like I was telling you earlier, the PDU, which is a complete sequence number. And as we can see, it looks like in our log right now that we're not seeing any of our routes from our loopbacks making it into any of our events that are going on. We don't see these added into our routing table. We're just seeing the L1 and L2 sequence numbers going through And so what we want to do next is we want to go through one more thing I want to show you. If I go, let's just say on R2, if I do a show route, probably saw this earlier. Now we have, in addition to the INET 0, our IPv4 routing table, we now have the ISO, our ISIS routing table. So pretty cool to see that going on. What we can see is we don't have reachability to router 1's loopbacks, and that is because if we look at our network diagram, we have not added, under the protocols ISIS hierarchy on R1 and R2, we did not set the interface for our loopbacks. We set the interface for our directly connected logical tunnels, so the next thing that we want to do is go under our loopbacks. I'm sorry, not under our loopbacks. We'll go under router 2 first. We'll go under edit protocols ISIS, and we're going to do the command set interface loopback 0.2. Let's go ahead and commit this, and what we should see is if we go back to router 1 and look at our trace option file that we were just looking at, we do a show log pipe to match 2.2.2.2, and now we can see that we have the 2 network coming up in our ISIS trace options. And it looks like it's being added to our routing table. We're showing the gateway of router 2. We're seeing the preference, and remember the lower preference is preferred. So we're seeing these coming in as L1. Because if we do a show ISIS overview, remember L1 has an internal route preference of 15. So if these were actually being learned as level 2, we would see 18. So if we go under router 1 and do a show route, we can now see the 2 network and the 22 network in our routing table. And the route preference is 15. So this tells us that they're being learned as level 1. And level 1 has preference over level 2, obviously. If we do a show ISIS database detail, one of the first things I'm going to point out under our ISIS database is that we can see that we have multiple database. We have ISIS level 1 link state database, and then we also have the ISIS level 2 link state database. Under our level 1 link state database, we can see that router 2 has the 2 network and the 22 network. And that's obviously what we have learned from router 2, and we now have that in our routing table on R1. We also see in our level 2 link state database that we have router 1 shows that it knows about the 2 network and the 22 network. And level 2, remember, it's just like OSPF, the backbone. So our level 2 link state database should have reachability to all of our prefixes that we add into, all of our networks that we add into ISIS. So your level 2 link state database should be more complete than your level 1 link state database. And that's why we see router 1 now advertising that it has reachability to those 2 networks. If we go on to router 1 and let's see, the next thing that I wanted to show you is that on R1 I can go ahead and ping. If I ping 2.2.2.2 rapid, we'll do a count of 100, and you see that we have reachability to the 2 network, and also we should have access to the 22 network as well. So we have reachability to both of those networks. If I go under router 2 and do a show ISIS database detail, just want to explain this as well. We can see under level 1, our link state database for level 1, we see that router 2 has the 2 network and the 22 network, and we see that from router 2's perspective, we don't have anything that we're learning yet from router 1. And that's because if you remember on R1 we haven't advertised its loop back into the edit protocols ISIS hierarchy. So that's the next thing that we're going to do. One last thing on R2, we see that the ISIS level 2 link state database is complete. We see R1 now showing that it has the 2 and 22. So the next thing that we want to go ahead and do is we want to go under router 1. We'll go under edit protocols ISIS. We're going to do the command set interface loopback 0.1, and then we'll go ahead and commit this. First thing we want to do, since we were just looking at router 2's ISIS database, let's go back to that. We'll do a show ISIS database detail. And now we can see from our, let's see, show ISIS database detail, we see that router 1 is now sending the 1 network and the 11 network. Router 2 has the 2 network and the 22 network. And for level 2, we see that router 1 and router 2, obviously they're both speaking as L2 routers in addition to L1 routers. So they both have the complete knowledge of all of the networks that are being added into our ISIS database, our ISIS network. And so what we want to do is, let's go ahead under router 2, let's go ahead and try to ping the 1 network. First thing, let's go ahead and do is show route. We can see now on R2 we have reachability to the 1 network and the 11 network. We're seeing this learned via ISIS. Route preference is 15. This is telling us that it's learned via a level 1 adjacency. We have a metric of 10. This is the default for all links in ISIS. If I do a ping 1.1.1.1, rapid count of 100, 100. We have reachability to the 1 network. We also have reachability to the 11 network. So let's go ahead and look at R1. If I do a show ISIS database detail, we can see that we are now under level 1. We are advertising the 1 and the 11 networks. We can see that router 2 is advertising the 2 and the 22 networks, and under our level 2 link state database we see both the 1 and 2 networks for both router 1 and router 2. So the next thing that we want to do, we want to make R1 and R2 just a level 2 only. The way we're going to do this is we're going to go under router 1. If I go under edit protocols ISIS, I'm going to do the command set level 1 disable. Because if I just look under edit protocols ISIS, if I just do a show, you can see that it doesn't show level 1 or level 2 at all. And that's because by default it's acting as a level 1 and level 2. So I have to manually go in and disable one of the levels if I don't want this router to act as one. In this case we're going to disable level 1, so we're going to do the command set level 1 and then disable. We'll commit this on R1, and then we'll also go to router 2, do the same thing. So we'll go under edit protocols ISIS, we're going to do the command set level 1 disable. And now what we're going to do is go back and take a look at our adjacency information on R1. If I go to operational mode and do a show ISIS adjacency, we can now see under the level it's showing us that this is a level 2 only. Another thing that I want to explain, because I'm not sure that I explained this earlier, we have the hold time timer in seconds, and then we also have what's known as the SNPA. And this is what we call the subnetwork point of attachment. And we are running frame relay between these two routers, so we don't see this information. But if we were running Ethernet, our different layer 2 encapsulation type, what this will usually come back as the MAC address of our interface that we have the adjacency over. In this case, logical tunnel 120.12. So this will come back as the MAC address of our logical tunnel. So one of the things that I want to show you on R1 is that if I go do a show log pipe to match ISIS lab 1, let's see, I'm sorry. If I do a show log ISIS lab 1 R1 and match on, let's see, what do we want to match? If we try to match on L1, let's do this. Let's go back in the log. We'll go to the last log, .0.gz. Let's go back one more. And we're seeing that we are deleting a lot of these level 1 connections, or the LSPs. We're seeing end L1 route installation, end L1 route installation, rejecting L1 routes. So what we have done is made the connection between R1 and R2, if we look at our network diagram, the connection between R1 and R2 is strictly a level 2 connection. And let's go ahead and look at that under our show. If we do a show ISIS database detail on R1, what we can see under the level 1 link state database is nothing. If we do a show route on R1, we can now see that the routes learned from R2 via ISIS now have a route preference of 18. And that is because if we do a show ISIS overview, level 2 routes are installed with a route preference of 18. So before, where both routers were acting as both level 1 and level 2 devices, level 1 was being preferred because it had the lower route preference. Now what we're seeing in our routing table as the level 2 routes I'm sorry, the level 2 route preference is being preferred, or I'm sorry, being added into the level 2 routes are being added into our routing table because the level 1 routes are no longer available. Just wanted to show you that we're seeing the same thing on R2. We go to router 2, show ISIS adjacency. We see the L, or the level we're seeing it as a level 2 now, whereas before we saw L3, which indicated a level 1, level 2. If we look at the database, we do a show ISIS database detail. We no longer see any prefixes or subnets under level 1. We're seeing everything under level 2. If we look at the routing table, we do a show route on R2. We can see that we have the route preference now of 18 for the routes towards the networks that we're learned off of R1, which is the 1 network and the 11 network. So the next thing that we want to do is change this just to a level 1 connection. We're going to do this. We're going to go under router 2. We're going to do the command set protocols. I'm sorry, let's just do this. We'll go under edit protocols ISIS. We're going to do the command set ISIS. I'm sorry, we're going to do the command set level to disable. So we're going to disable level 2, but now we have to re-enable level 1. And we're going to do that with the command set. We're going to do delete level 1 disable. So by deleting the level 1 disable, we're actually enabling level 1. Might sound confusing. That's just the way it is. Let's go back to router 1. Do the same thing. We'll go under edit protocols ISIS. We're going to do the command on R1 set level 2 disable, and then delete level 1 disable. And if I go to router 1 and do a show ISIS adjacency, what we see on R1 is that it is a L1 now, or level 1 connection. If I, on R1, look at our trace option, we'll do a show log ISIS lab 1 R1, and we'll match on L2. Now we can see that we've seen the deletion of the link state PDUs from R1. We're seeing all the L2 routes being rejected. And we're seeing ISIS L2 neighbor, let's see, we are seeing some neighbor statements on R1 in regards to its L2 connection. This is obviously saying that the connection went down. We're seeing the deletion of the LSPs, the rejection of the level 2 routes. All of these indicate that the connection is now an L1 connection. If I do a show ISIS database detail, we can now see that the ISIS level 1 link state database is complete with the routes originating, the ones from R1 and the ones from R2. And we can see the ISIS level 2 link state database is blank. I can go on furthermore on R1 if I do a show route. If I look at the networks that I learned from router 2, the 2 network and the 22 network, they are now coming in ISIS with a route preference of 15. If I do a show ISIS overview, we can see that for level 1, internal route preference is 15. On R1, let's go ahead and do a ping. We see that we have reachability again to the 2 network. So let's just verify this information on R2. If I do a show IS-IS adjacency, we can see that the connection to router 1 is a level 1 connection. If I do a show IS-IS database detail, the level 1 database is complete and there is an absence of prefixes in the level 2 database, and that's because we are no longer running the connection between the connection between R1 and R2 is no longer a level 2 adjacency. It's strictly level 1. If I do a show route, we can see the routes coming in with the internal level 1 IS-IS route preference of 15. Let's go ahead and try to ping these. And we have reachability. So that has been Juniper Intermediate System to Intermediate System IS-IS Lab 1. In this lab we looked at the basics of IS-IS. We explained some of the basic operations in detail about IS-IS, that it is similar to OSPF. You have different levels of routers. You have level 1s, you have level 2s, then you also have level 1, level 2s. A level 1, level 2 represents and is very similar to an OSPF area border router. We're going to take a look in detail about the level 1 and level 2 information and router types, also level 1/level 2 routers, in the next video, which is going to be on running IS-IS in a more advanced network type. So we're going to have multiple routers in that scenario and explain in detail the differences between the different levels of routers. We looked at the net ID, not the net ID, we looked at the net address, our network entity title, we explained that in detail, and then we also just enabled IS-IS under Edit Protocols IS-IS, and also under the interfaces between the routers. I want to thank you for watching, and I hope to see you in the next one.